Hello, good day everyone. You're welcome back. Like you saw in the title of the video, we did a kind of test yourself question. We are looking for the best geometry solver on YouTube, and that may be you. So how we're going to do it, we are going to solve this question to some extent, then you solve it to the end and give us your final answer with your name. So let's go. Now the question says calculate the surface area of the blue colored portion if this side P and the radius drawn next to it, which is here, are equal in length. And this arc AB is 416.45 millimeters. So how can we solve it? Let's start with this side here. It has a length 385 millimeters. We can see it is a chord of the circle, and the formula for calculating the length of a chord is 2r sine 1 over 2c. If we equate that to the length, 2r sine 1 over 2c equal to 385 millimeters. C is the central angle, that is the angle it subtends to the center. But recall, any angle an arc subtends to the center is twice the angle it subtends to the circumference. So if we draw out the angle it subtends to the circumference, since the angle at the center is C, this will be C over 2, which is the same as 1 over 2C. Now if you look, this line here is a tangent to the circle at this point here, and it is intersecting with this chord here. There's another rule from the circle that the angle between a tangent and a chord through point of contact is equal to the angle the chord subtends to the circumference. This angle 80 degree is the angle between the chord and the tangent, and this angle is the angle the chord subtends to the circumference. Based on this rule here, this and this angle are congruent, that is 1 over 2c equal to 80 degrees. So if we substitute here, 2r sine 80 degrees equal to 385 millimeters. Dividing both sides by sine 80 degrees. Here 2 cancels 2 and sine 80 degrees cancels sine 80 degrees. While here 385 millimeters over 2 sine 80 degrees, if you press your calculator, is approximately 195.47 millimeters. So R, which is radius, is 195.47 millimeters. Now this at AB, they said, is 416.45 millimeters in length. The formula for calculating the length of an arc is theta over 360 times 2 pi r. Theta is the central angle, which is C. If we equate it to this length here, now C over 360 degrees times 2 pi r equal to 416.45 millimeters. R is the radius, which we have here as 195.47 millimeters. Here, C over 360 times 2 pi times 195.47 millimeters, if you simplify, is 3.413 millimeters. So dividing both sides by 3.413 millimeters, here 3.413 millimeters cancels 3.413 millimeters, and here 416.45 millimeters divided by 3.413 millimeters is 122 degrees. So C, which is the central angle for this arc AB, is 122 degrees. Note, this point is not the center. This is the center because it is the point from which this radius was drawn to the circumference. And if you look, this is also a radius because it was drawn from the center to the circumference. And that implies that this and this angle here are equal in sizes. So since this is 60 degrees, this must also be 60 degrees. And this will be 180 degrees minus 60 degrees minus 60 degrees, because the sum of angles in a triangle is 180 degrees. 180 degrees minus 60 degrees minus 60 degrees is 60 degrees. Now since this is a sector, the formula for calculating the area of a sector we know is theta over 360 pi r squared. Theta is the angle at the center, which is 60 degrees, and r is radius, which we have to be 195.47 millimeters. So area of sector equal to 60 over 360 times pi times 195.47 all squared, which if you press your calculator is approximately 20,013.99 millimeters squared. So the area of this sector here is 20,013.99 millimeters squared. Now coming back here, if we draw a line that connects this point and this point here, this here is a segment, And the formula for calculating the area of a segment is area of sector minus area of triangle. Area of sector we know is theta over 360 pi r squared, and area of triangle of the sector can be calculated by the formula 1 over 2 r squared sine theta. Theta is the central angle, which we have to be 122 degrees, and r is the radius, which is 195.47 millimeters. So area of segment AB equal to 122 over 360 times 5 times 195.47 all squared minus 1 over 2 times 195.47 squared sine 122 degrees. If you press the calculator, it will be 24,493.78. So area of segment AB is equal to 24,493.78 millimeters squared. We can also apply the same formula for this segment here. Earlier, we found half its central angle to be 80 degrees. That is, the central angle is 2 times 80 degrees, which is 160 degrees. And radius is 195.47. If we substitute now, area of segment equal to 160 over 360 times 5 times 195.47 all squared minus 1 over 2 times 195.47 all squared sine 160 degrees. This also, if you press your calculator, is 46,836.59. So area of the segment is 46,836.59 millimeters squared. Now this is where we are going to stop, and the best geometry solver on YouTube is going to tell us the final answer to the question. That is the area of the blue colored portion here. I look forward to meeting you, sir.